component. This is way. This is how Maxwell been compliant with ISO 26262 functional. This is, how the ANSYS Maxwell simulation tool can minimize the risk and failure. We're going to learn about that based on the case studies has been introduced. How various errors occurring, during the design process are detected and ways to address them, and building confidence and trust in the delivery of the final motor design that fully complies with ISO 26262. Again, it's very important to understand based on the supporting design, the compliance, and identifying those good practices and best practices using Maxwell software, simulation software, to address different hazards and to address and detect, different risk problem with the design within the design process. As evaluation of the assessment-based functional safety compliance, this ISO 26262 certification generate, two use cases for as far, Maxwell simulation package is concerned. We define the electric drive validation, one use cases, electric drive validation, and everyone is familiar with the technique of reducing the size of a 2D or 3D physics-based solution into the system integration to make sure the component is being extracted from the ANSYS Maxwell simulation is going to be compliant with the safety regulation from a system validation standpoint. And the second important use case is defined within ISO 26262 relates to electrical machine virtual testing. And we're going to be able, to see that this virtual testing, it's emulating, a hardware testing, defined by IEEE standards related to electrical machine manufacturing. How this, it's compliant, or how this is translated into the Maxwell environment. Specify and reference the features, functions, and technical properties of Maxwell of simulation tool, which are applied to functional safety design. And we're going to be able, to exemplify a couple of, these reference features, when you are concerned with extraction of the model from Maxwell simulation into system, and also when you perform a virtual test of an electrical machine design. Consider the behavior under anomalous, operating conditions. Describe the known software tool malfunctions and the appropriate safeguards, avoidance, or workarounds measure. Every simulation tools user is very familiar with this type of, software tool behavior when used for designing and analyzing different operating conditions. And in Maxwell, language, we translate this type of, situations when user define the material characteristics using the design space, when the user, define the proper mesh to be able to predict, in more accurate the different type of characteristics from losses to derivative characteristics. When the user it's using different type of features and capabilities, workflow capabilities within the software to be able to predict different type of operation of the design. And last but not least, identifying the measures for detection and malfunctioning and the corresponding erroneous output of the software tool. In other words, and we're going to be able to see that you properly define a design, a component design within Maxwell environment, and Maxwell software does not provide autos. Maxwell software does not solve, properly the solution. What you need to do, what you need to keep in mind when you go back and to validate, the proper setting of that particular, component. Those things, collectively generate, this type of, evaluation of the assessment base for functional safety compliance. As I already mentioned, ANSYS Maxwell, it's using in this certification two important use cases, and all the derivatives from these use cases can be used towards safety compliance. Electric drive validation. Everyone is familiar with an electric drive from an EV, HEV road vehicle perspective point of view. We are talking about with generation of individual components from the system integration, from the source of energy, which in this situation is the batteries, the power electronics, and the electronic components are regulating the energy transfer between the source and the consumer, and in this case the consumer is an electrical machine. And last but not least, the embedded code, which is controlling the operation of electronics, is controlling the operation of electromechanical components are as part of the electric drive. And this is we call the ROM system integration. It's a reduced order model system integration. This is trying, to translate a little bit, the way of using and the way simulation software as Maxwell with, the safety compliance and the safety requirements and the safety language of ISO 26262. In a very similar fashion, we introduced the second use cases, and this relates to electrical machine virtual test, where the user generated a design in a Maxwell environment, analyze this design, and before going into manufacturing the design for to comply with the standards of verification of validation of the final product, is going to do all this simulation virtually, is going to do all this simulation using the software. And this is, use case relates to open and short circuit tests, which are well standardized under IEC and later on IEEE standards. Failure mode and effect analysis. This is a typical definition. This is a typical terminology within safety regulation standards. Failure mode and effect analysis can be translated into the software simulation. Again, in the left-hand side, we see the two use cases, and we see the potential malfunctions and erroneous reporting related to ANSYS Maxwell. For sake of an example, assuming that you have a design in Maxwell environment and you want to export an equivalent circuit or a corresponding reducer model from a 2D or a 3D simulation into the circuit simulation for further validation. One potential malfunction once you you define the design is that the tool, in this case, ANSYS Maxwell, does not generate the circuit simulation model. And the immediate impact, the natural consequence of that, the system integration cannot be performed. This is a justification for the tool impact. This is a very, very specific, oriented language, ISO 26262 oriented language. And Maxwell certification, provides the guidance where and how you should be able, to revisit, your design to make sure that Maxwell has the required, input information to generate, that circuit simulation, to generate that reducer model environment. A second important, malfunction can be achieved during, this design process. Maxwell is able to generate a model, the generated circuit simulation model or generated reducer model does not validate the system response. Generating a physical, model and being able to integrate this model into the circuit and system environment, the system, simulation cannot be validated virtually against the safety requirements. What to do? And Maxwell guideline put together a list of what to do to make sure that the obtained circuit model or obtained reduced order model fulfill all these requirements, validates the system response against the safety requirements. These are, these are the guidelines of identifying and addressing the risk from a system standpoint, but maintaining, the view at the level of component design. From a second, case study on Maxwell, and this relates to the virtual testing of an electrical machine. One potential malfunction of Maxwell is the tool does not provide the correct open circuit characteristic, does not provide the corresponding, clogging torque characteristic, induced voltage, and so on and so forth. Not providing this type of, characteristics, the tool impact relates to the fact that the user cannot, predict the back MF to validate the back MF according to the safety regulations. And the certification process put together all the best practices, what the user needs to do to be able to fulfill those requirements. It needs to be able to obtain and to predict accurately the open circuit characteristic. And you can imagine, having experience of Maxwell usage, you can imagine this goes from proper geometry import, proper material assignment, BH characteristics, proper mesh operation, and proper, definition of rigid motion to be able to capture the clogging torque and to be able to generate the induced voltage to be compliant with the standards. A second important, aspect of this second case scenario, potential malfunction, unreasonable short circuit currents prediction. It's exactly the same type of, behavior as previous, but on the short circuit environment, how to properly calculate the short circuit characteristics of an electrical machine from a given, simulation, and how the simulation can emulate already, predefined bench assembly required by standards to validate, the final product. These are the error detection and prevention methods. Exactly as I mentioned and I explained in the previous, slide, detecting the possible malfunctions, errors, and defining the prevention methods, what the user needs to do at the level of the tool simulation, at the level of ANSYS Maxwell, to be able to address those errors and to mitigate those errors. The standards provide steps to avoid design failures of ANSYS Maxwell for not being able to generate proper circuit simulation model in case of an electric drive validation when the user needs, to export an equivalent circuit or export a reducer model for the system integration. And when this happens, to be able to validate against the safety condition, exactly as I mentioned. The process becomes more complex because once you export an equivalent circuit or a reducer model from an ANSYS Maxwell simulation into the system, you have several components which are interacting with each other during the simulation validation process. In the similar fashion, the electrical machine virtual test, the standard provides steps to avoid design failures of ANSYS Maxwell solution when Maxwell is not able to provide user with correct open circuit characteristics or predict accurately, short circuit currents. What the user needs to do to be able to mitigate and to prevent those to happen. This is the foundation of safety compliance specified by ISO 26262, and Maxwell is required to fulfill. These are a little bit more explanations and on each